Good afternoon, Mrs. Agarwal. The steps of muscle contraction are as follows. The first step is depolarization and calcium ion release, where an action potential from a motor neuron triggers the release of acetylcholine into the motor end plate, and the acetylcholine initiates depolarization within the sarcolemma, which is spread through the muscle fiber by T-tubules, and the depolarization causes the sarcoplasmic reticulum to release stores of calcium ions. The calcium ions play a pivotal role in initiating muscular contractions. The second step is actin and myosin cross-bridge formation, where on actin, the binding sites for the myosin heads are covered by troponin and tropomyosin, which there are essentially a blocking complex. Calcium ions bind to troponin and reconfigure the complex, thus exposing the binding sites for the myosin heads, and the myosin heads then form a cross bridge with the actin filaments. And the contraction of the skeletal muscle is achieved by the sliding of actin and myosin filaments, and ATP hydrolysis and cross bridge formation are necessary for the filaments to slide. The third step is the sliding mechanism of actin and myosin, where ATP binds to the myosin head, breaking the cross bridge that the actin and myosin formed. And then the ATP hydrolysis causes the myosin heads to change position and swivel, moving them towards the next actin binding sites. And the myosin heads bind to the new actin sites and return to their original conformation. And this reorientation drags the actin along the myosin in a sliding mechanism. And the myosin heads move the actin filaments in a similar fashion to the way in which an oar propels a rowboat. And the fourth step and the last step is sarcomere shortening, where the repeated reorientation of the myosin heads drags the actin filaments along the length of the myosin. And as actin filaments are anchored to Z lines, the dragging of actin pulls the Z lines closer together, shortening the sarcomere. And then as the individual sarcomeres become shorter in length, the muscle fibers as a whole contracts. Thank you for listening and have a good day.